Welcome back to the channel. In this video, we are introducing circles for analytical geometry grade 12. A circle, as you all know what a circle is, it's basically a set of points which are actually equidistant from a fixed point. That fixed point is actually the center of the circle. So there's just a bunch of points like that which are very close to each other, and all of them, they are equidistant, or they are of the same distance from this point in the middle, which is the center of the circle. So that therefore means the distance from the center to each point is the radius of the circle, and we can determine the length of that distance by using the distance formula, because it's still the length, so there's nothing special about it. You'll have the two coordinates. If the center of the circle is at the origin, that means the coordinates of the origin is 0 and 0. So to determine the length, you have the coordinates of the origin, which is 0 and 0, and then you have the coordinates of an arbitrary point P there, which is just x and y. So to determine the length of OP, we're just gonna use the distance formula, substitute these two coordinates, and you can see this is what you will end up with. As a result, OP squared is going to be x squared plus y squared. But then from this equation, you can tell that OP, it's actually the radius. If you remember from when you were using the distance formula, trying to calculate the length of any distance between any 2 points, this, as you can see, you can just take the square root of it to get the length of OP. So instead of doing that, of which there's no need at this point, we're just going to leave it as the square. So this will therefore mean R is actually OP. As you can see from your sketch, R is actually OP. So just replace OP by R, then you get R squared. Then now you know that the standard formula for a circle whose center is at the origin, it's given by that x squared plus y squared equals to R squared. So we're going to do a couple of examples or questions rather related to a circle whose center at the origin in this video, so that you can see how you can use this equation. Just remember that a circle, it's basically a graph like all other graphs, so there's nothing really hectic, or you don't need to change the rules about a circle. So what you need to remember with other graphs like the linear graph, parabolic graph, the standard equation, even though it had other variables, when you're required to derive the equation, you only leave it in terms of x and y. So that means all the other variables, you must determine their values and write the constant instead of the variables. Put their values instead of the variables themselves. So that's exactly what we're going to do even with circles. Okay, let's just look at example 1. A, we are required to determine the equation of the circle whose center, the origin, and the radius, it's 5. Because they are saying it's a circle with centered origin, we're going to use this standard form. And because we are given the radius, we're just going to substitute the value of that radius. And that means our equation is given by x squared plus y squared equals to 25. That is as simple as that. Okay, let's look at B. Determine the equation of the circle with centered origin, which is passing through the point -2 and 4. Again, because it is a circle with centered the origin, the standard equation is that. We are given a particular point, so we can substitute that point into the equation. When we substitute, we get this, because it has an x value and a y value. We're just going to substitute like that. And this is 4 plus 16, which is 20, equals to R squared. Therefore, R squared equals to 20. Okay, now that we know what R squared is, we just need to rewrite the equation in the standard form. Then that gives us the equation of the circle. Okay, example 2. There's a point which is provided there, b and -8, It is said to be a point on the circle which has the equation x squared plus y squared equals to 17. And then we are required to answer these three questions, A, B, and C. A, we are required to determine the possible values of B. Let's just deal with one question at a time. So this point is on the circle, and there's an unknown coordinate, which is the x coordinate of that point. But because the equation of the circle is actually complete, we just need to substitute that point on the equation of the circle for us to find the unknown coordinate. So that's exactly what we are about to do. And the y is negative root of 8 equals to 17. So this gives us 8 plus b squared equals to 17. So b squared is therefore equals to 9. Therefore b is equals to plus minus the square root of 9. Thus b is actually equals to plus minus 3. Therefore b equals to 3, or b equals to negative 3. So those are the two possible values of b. Okay, moving on to b. What are we required to do? We're required to find the x and the y intercepts of the circle. Like I said, there's nothing special about a circle. It's just a graph like all the other graphs that we've dealt with before. So for x-intercept, we let y equals to 0. For y-intercept, we let x equals to 0 in the very equation of the circle. So let's do that. For x-intercept, that is just let y equals to 0. We are given the equation of the circle equals to 17. And then letting y equals to 0 here, that means we are left with 0 here. Okay, and therefore x squared equals to 17. As a result, x is actually equals to plus minus the square root of 17. Therefore, x actually equals to the square root of 17, or x equals to negative the square root of 17. And then, like in all the other graphs, you remember the intercepts are actually coordinates. So the results are root of 17 and 0, or negative the square root of 17 and 0. Okay, and let's look for y-intercepts. Okay, it's actually intercepts as opposed to an intercept. A circle has two intercepts, or two sets of intercepts. We let x equals to 0 for y-intercept. Remember, we're still using the same, sorry for that, we are still using the same equation since we are still on the same circle. So we let x equals to 0, okay, plus y squared equals to 17. Therefore y squared equals to 17, which therefore means y is actually equals to plus minus the square root of 17 again. As a result, y is actually equals to negative, or maybe let's start with the positive root of 17, or y equals to negative root of 17. As a result, we have the coordinates of our intercepts, 0 and root of 17, or negative root of 17 and 0. Wait a moment, this is not how it's supposed to be. The x is the one which is 0. Okay, sorry for that, negative square root of 17. Okay, those are your intercepts, the x and the y intercepts. Okay, let's look at C. C, we are required to find the other point with integer coordinates that lies on the circle. So just so that you can visualize how the situation actually looks, I'm just going to try to draw the circle. Okay, let's insert that circle here. Suppose this is the circle which is given, okay, which represents that, or represents the equation which is given. The circle has its center at the origin, and the equation is given as x squared plus y squared equals to 17. So we know that the x coordinates, or the x-intercepts, is negative 17 and positive 17, similar to the y-intercept is positive 17 to negative root of 17. Okay, this is what you have. So now if they ask you for another point which is on the circle but it has integer coordinates, you can think of any point which is maybe here, maybe here, maybe here, maybe here. You can just think of any point which is still on the circle like that. So for it to be within the circle or on the circle, its value of x or y cannot be greater than the square root of 17, because if it's greater than the square root of 17, it is outside the circle, as you can see. So its x value and y values cannot be greater than the square root of 17. So think of anything which is less than the square root of 17 and try to check if its two coordinate values, they are actually integers. So how are we gonna go about that? First, we need to know what is this square root of 17. The square root of 17 is actually it's 4.12 something like that. So you would already see that if it's 4 point something, that means we need to look at the integers that we need to consider. It's like 4, 3, 2, 1, and is 0 an integer? I think so. So we need to only consider those 1, 2, 3, and 4. So we're just gonna look at let's look at 1, because 1 it's very easy to deal with. It doesn't involve a lot of mathematics there. So suppose we test 1. The equation is this: x squared plus y squared equals to 17, right? Suppose we check with 1, we substitute there, we try to find its corresponding y value to see if it's actually also an integer, because the question is asking us to find another point which is still on the circle. We know that 1 is actually on the circle. It is an integer coordinate which is on the circle, but we have to find its corresponding y value and check if it's also an integer, because both x and y are supposed to be integers as we are instructed. So y is actually going to be plus minus the square root of 16, which means y is actually plus minus 4. So for x equals to 1, we have integer coordinates. So we have another point actually which is on the circle. That point is actually 1 and 4, or 1 and negative 4. So we managed to find another point which is on the circle and it has integer coordinates. It lies on the circle and it has integer coordinates, so we are actually done. To try to not make this video too long, I'm just gonna leave it here and then we look at an exercise in the next video.